Greetings, everybody. We're going to look at multiplying polynomials today. Hopefully, this should be somewhat of a review for you. Our learning target is to multiply polynomials using a graphic organizer. So we're going to be using the rectangle. So let's look at our first example. This is something you've done, I'm sure if you're in Algebra 2 now, you've done this multiple times. Just to review and set up our harder problems here, though, we're going to go through this one. So I need to multiply two binomials here, and you could use FOIL, first, outer, inner, last. It gets a little confusing, I think, when we get to the larger polynomials. So we use what we call a graphic organizer. It's a rectangle, sometimes called a generic box. Okay, so or generic rectangle, one or the other. Okay, so we're going to put our first binomial on the outside here, and then we'll take our second one and put it over here. Now make sure you bring the sign with the 5. The 5 is negative, so make sure you bring a negative with that. And we're going to multiply to get the insides of the box. So we're going to do 2x times 3x, which is 6x squared. And 3x times negative 5 is negative 15x. We're going to do 2x times 2, which is 4x. We're going to do 2 times negative 5, which is negative 10. At the very end, we'll add any like terms. And so our final answer here, this expression is equivalent to 6x squared minus 11x minus 10. And again, notice, importantly, I put an equal sign here. These are equivalent expressions. We call this the area as a sum, and this original one up here we call a product, because we're multiplying two binomials together, and we're rewriting it as a sum. Okay, we'll reverse that process when we get to factoring, where we'll go from a sum to a product. Okay, the next product we're going to look at is a little more complicated. Notice we're multiplying three binomials together here. I want to take us to a simpler problem just to get across a point. I want to look at just some numbers here. What if we had to multiply three numbers together? Think about that for a second. Could you do all that in one step? What you think there? The answer is no. You'll have to take it in parts. You could do this multiple ways. You could say 4 times 5 first, which is 20, and then multiply by 2, which gives us 40. We could have also gone 5 times 2 first, which is 10, and we'll get the same answer there, 40. I could have gone one other direction. I could have said 4 times 2, which is 8, and 8 times 5 is 40. Notice we end up with the same answer every time. The point here being, you can't do 4 times 5 times 2 all in one step. So let's go back and look at our other example here with polynomials. So when we look at that example, the point is, I have to pick two to work with first, and that's why I have two rectangles here. So I'm going to pick the first one here, the first two, I should say, and we're going to multiply those together. So I'm going to, again, put my first binomial on one side of the rectangle, my second one over here on the left, and I'm going to multiply. I'll go ahead and fill in these boxes here. Okay, and just check your steps as you go along because there's a lot of pieces here. So you just kind of mentally go through and look at the box once you multiply and make sure you got everything right. Now again, we're going to combine like terms. So the answer for this green part is 2x squared plus 9x minus 5. Now that's equivalent to these two binomials multiplied together. So we're now going to bring that over here to our rectangle. Notice we're going to need a 2 by 3 this time. And I'm going to put down my green piece here, which is a trinomial. And then I'm going to pull in the other piece over here, the blue part. I'm going to multiply by that. So hopefully you're seeing the analogy there, the connection to multiplying three numbers and how we could choose a different order. Okay, so equivalently what I just did was kind of a 20 times 2 first. Okay, so I did the green, represents the 20, the 4 times 5. Okay, so now I'm going to just finish this problem off by multiplying the remaining pieces here. So I have to be careful. 2 times 3 is 6, and x times x squared is x to the third, following our properties of exponents. And then I've got 27x squared right there, and then this is going to be negative 15x. And do be careful with your exponents as you go along. This is going to be 8x squared down here, and I'm going to get 36x. I'm going to get negative 20. Now at the very end of this process, we'll add any like terms. So I have 6x to the third is by itself. And then I'm going to add a couple like terms here. So I'm going to look at specifically right here. Those two pieces are going to add up to 35x squared. So I'm going to put those pieces there, or that piece there. And then I've got these x terms here I need to add together. So if I take 15 away from 36, I end up with 21x and minus 20. I'm going to box in my answer. That's the solution for multiplying these three binomials up top here. So this is equal to this. Again, this is a product up here. We call this a product. And down here we have a sum. But they are equivalent. They are equal to one another. So if we were to graph them, either form, they would give us the same graph. If we were to solve them, they would give us the same. If we had them set up as an equation, they would give us the same answers. Okay, our last example here, basically the same idea, just without the three binomials. We're taking a trinomial times a binomial. So you think about your rectangle being a 2 by 3. So I'll put my binomial here where the 2 boxes are. I'll put my trinomial up here where the 3 boxes are. And then I'm just going to multiply to get the boxes, and then I'll add like terms at the end. So this is 3x to the 4th, negative 15x squared. We have 39x. We have negative 2x to the 3rd, positive 10x, and negative 26. So do be careful with your signs. And at the very end, again, we'll add any like terms. 3x to the 4th stands on its own. And then we have negative 17. Actually, the cube stands on its own too. Negative 2x cubed. We have a negative 15x squared. We do have two like terms here, which will give us 49x minus 26. Okay, so in summary, my final answer is down here at the bottom. That's my final answer, and that's equivalent to this expression, just like I said earlier in the earlier examples. Okay, so that summarizes our multiplying polynomials using a rectangle or a graphic organizer, as we call it. Have a great day.